Assalamualaikum and good morning to Dr. Nur Aidawati, our lecturer Instrumentation and Control. Today our group want to present about the instrumentation and control system in the PLC Convenyor software. This is our group members. First, my name Nafis bin Nazri. Second, Yizo Shen. Third, Ninjumin, and last, Tae Su Chen. Based the video our group watch, sorting systems are used to the bridge between production and packaging machinery. The sorting systems are used to sort items based on the variance criteria so that they can be packed accordingly. The manual sorting system take a time and effort intensive process. Besides that, the automatic sorting system allow for fast and efficient sorting product. To demonstrate the sorting system, we developed a PLC-based sorting system project that use piston with color sensing system powered by PLC control to achieve the functionality. The system consists of the conveyor belt to carry product from one to end a collection basket. It contains a color sensor to send the types of product using the color sense. The system now utilizes 3 pistons with piping and control valve to control their operation. The system is powered by PLC to control the sorting system. The 3 collection baskets are used to collect a sample sorting by the piston mount parallel to each one. The PLC coordinates with sensor and piston valve in order to achieve the desired functionality and demonstrate the fully automated product sorting system. This is a problem statement our group get. First, how does the PLC convention software detect the object and clearly push the object into the right place? Second, the current instrumentation device used in the PLC convention software is only proximity sensor. This sensor is not very accurate. Third, a proximity sensor often emits an electromagnetic field or a beam of electromagnetic radiation and look for change in the field or return signal. Last problem statement our group get is different proximity sensor target demand different of sensor.
Okay, so thank you for the presentation from Nafis, and I'm Lida Shen, and I'm going to continue the presentation about the definition of the capacitive sensors. Okay, so for capacitive sensors, they are non-contact device that can detect the presence or absence for any object regardless the material. Okay, besides that, a capacitive sensor have some similarities to a radar, which can detect the conductive materials while seeing through the insulating materials such as wood or plastic. Okay, so they are also different when compared to radar. Okay, capacitive sensors are more simpler, and their size are more smaller, and they are less expensive. Okay, for capacitive sensors, they do not give a direction indication or how far away the detected object is. A more distant strong target can give the same response as a nearby weak target. Yeah. Okay, besides that, a capacitive sensors are non-directional and have a short range compared to a radar. Okay, so now I will continue my presentation about the operating principle for capacitive sensors. Okay, there are 2 plates in a capacitive sensor, which one of the plate is metal plate in the sensing phase of the capacitive sensors is electrically connected to an internal oscillator circuit, and the target to be sensed acts as the second plate of the capacitor. Okay, so the capacitive sensors will produce an electrostatic field. The external capacitance between the target and the internal sensor plate form a part of the feedback capacitance in the oscillator circuits. As the target approaches, the sensor to phase the oscillation increase until they reach a threshold level and activate the output. Okay, so the sensitivity of capacitance can adjust by adjusting an potentiometer or even physically move for sensing the target correctly. Okay, due to large increase in sensitivity can cause the sensor to influence by temperature, humidity, and dirt. Okay, there are two categories of target that capacitive sensors can detect, which first of the target is conductive targets and the second target is non-conductive targets. Okay, the conductive targets include metal, water, blood, acid, bases, and salt water. This is because these targets have a greater capacitance and a target dielectric strength is immaterial. Okay, so now I will continue pass the presentation to Tay to talk more about capacitive sensors.
Hello doctor, my name is David Cheng and I'm going to present about the sensing range of a capacitor sensor, schematic diagram, and the formula related. The sensing range of a capacitive sensor is the sensing range. The capacitive sensor have a larger sensing distance than the inductive proximity sensor. The capacitive sensor typically falls between 5 to 40 millimeters. The detection range of the capacitive sensor depends on the plate diameter. The longer the plate diameter, the longer the detection. The capacitive sensor is equipped with sensitivity adjustment controls. This is the schematic diagram of a capacitive sensor, and this is the sensing element. The capacitive sensor interface is mainly composed of relaxation oscillators, multiplexers, a fast counter, which is external counter, and microcontrollers. The relaxation oscillators convert the capacitance values of the sensing elements to a periods modulate outputs. The counter measures the elapsed times of periods, and the multiplexer selects the measured capacitance. The microcontrollers control the external counter and multiplexers. And this is the formula related, and the capacitance refers to ability of body to store the electrical charge. It is expressed by following equations, and C equals to capacitance in units of farads, A equals to areas of overlap of plates, and D equals to distance between two plates. And E is the permittivity of free space, which is 8.854 times 10 to the power of negative 12 F per m, which force over meter, which is equals to the pressure. And E is the relative permittivity of dielectric material between two plates.
Good morning to Madam Aida. My name is Lim Jung. So next I will continue to calibration planning. Capacity sensors are precision distance measurement instrument. Some models achieve non-linearity of 0.02% or better over the full measurement range, making capacity sensor the most accurate electrical sensor available. In order to provide best accuracy, every sensor, electronic module, and probe are calibrated over the required measurement range on a nice traceable calibration stand at our factory before shipment. During the calibration, the resolution of the sensor is also measured using a precision multimeter. A calibration certificate is shipped with every sensor and maintained electronic database of all calibration. So the National Institute of Standards and Technology first, they will check the capacity sensor and through the wavelength and also the frequency. And the wavelength is checked by the Heine laser. It gives the iodine stabilize and go to the next process wavelength, and the frequency goes to the next process of frequency, and they also have a new is digital DMM is digital multimeter, and the wavelength is also checked by the Agilent laser 5517B, and the frequency is also the frequency standard, and then the DMM is also the digital multimeter. Next, the Agilent laser 5517B and also the frequency standard will give a wavelength, and this is checked by the Agilent laser 5517B again, and the frequency standard is also checked with the digital multimeter and give a is checked by the Agilent 5 power 1/2 digital multimeter 3458A, and then the Agilent laser 5517B will give a linearity, which is the linearity is stable or not, and then the Agilent 8 power 1/2 digital multimeter 3458A give the noise, which is the noise is stable, and linearity and the noise are stable, give a capacitive sensor. So I think that's all for me. Thank you.